Just raise your hand if you're already using 4D. Good. An easier question. Who is familiar with 4D? Who's ever heard of it? And even easier, who's heard of Hydro-Quebec? Okay, so we're in business. I'm an advisor for scheduling and estimating at Hydro-Quebec, and Hydro-Quebec has been doing 4D since 2009. I joined Hydro-Quebec in 2010, and as far as BIM is concerned and PLM, we've been involved in this since 2004. So we were kind of pioneers in Quebec for this. So thanks for being there. And let's move right in with my outline. I'm going to be dividing into two. First of all, more concepts, and then I'll be giving you more concrete examples. So first of all, how do you actually do a 4D? I would describe it at Hydro-Quebec and give you some benefits we've seen, and then give you an idea, an illustration, and some examples of use and goals and levels of detail, as well as a few examples of projects in which we implemented with 4D, and then the interoperability context with respect to choice of various companies with respect to 4D. And finally, I will end with recommendations, limitations, challenges, and my conclusions. So how do you actually do 4D? Jean's going to be happy. On the one hand, you have your input, which is a 3D model. We use CATIA a lot. We have a lot of other software. But if you use a lot of 4D inside Hydro-Quebec, you know that CATIA is really what we use. That's digital modeling. And then separately from that, we have another input, which is the schedule. And we use Envera. We used to have MS Project, but now we use Envera. And we integrate this through macros in CATIA so that we end up with a deliverable 4D with the 3D via model of Dassault. And then we have something that's auto-executable in .exe, and then we have videos with narration about our projects. So that's for how we actually put it all together. A little bit about us. It was my privilege to work on this since 2010. We've written 4 articles recently on the topic involving 4D and Hydro-Quebec. Initially in 2012, we wrote together with the AACEI, and we were using Delmia and Microsoft Project, as I've already said. Then last year, I wrote another article together with the AACEI dealing with Envera and 3D Via. Then we did another article with IEEE where we were looking at functionalities in 4D for criticality visualization. And I'll show you this later. And then more recently, we had a visualization of delay claim analysis using 4D simulation. And that was with the ASCE. And this is 2018, the ASC being the American Association of Civil Engineers. So what are the benefits? If you're not familiar with 4D, or even if you do know about it, I can tell you what we've experienced. We had a selection of scenarios. We had the constructability. We could validate the contract dates. We could visualize interim acceptances and milestones. We could look at the interfaces, interferences, and operating constraints. We avoided having problems during the construction period. And more recently, we've included movements and displacements, assemblies, deliveries, and storage. More recently, we've also included constraints involving personnel safety, looking at workspace and confined spaces and working on top of each other and having multidisciplinary teams working. Why is 4D important? Well, there's an increasing level of interest, and I can see this here today. In 2016, ENR wrote on their cover page about the marked interest for 4D schedulings and how it reduces project risk. It's revolutionized planning because it creates stronger links between experts and planners and the people out in the field. And you can have appropriate scheduling earlier in the project. We found that we had practical files of reasonable sizes. That helped us in strategic decision making, and it helped the staff on site with operational considerations. And when people get to the work site, where it's possible, in some contracts, you give them a 4D in their sort of welcome package. And it's already available right at the startup before construction even begins. So that's how it works now. So how do you prepare a 4D project? Maybe you're already doing it with other projects and other software. What we do, we start with the time frames. We do that according to best practice. We look at a certain number of agendas, calendars, smart assessment of constraints, things like that. And then we have to look at time frames, how long things take. There's all kinds of best practices. We look at various types of scheduling. We consider whether we're dealing with the lead contractor or builder. We can also look at particular contractors, whether we're looking at a baseline or an update. For the fields to be considered for our associations, we'll look at the tasks, the length it takes, the start date, end date, and color choices. We can also add in intermediary milestones for every task. And we can create a certain number of fields defined by the users to illustrate action ratings, comments, and 3D parts, etc. All of this is put together with WBS. So moving forward, we look at the planning and the estimates. If you're in 3D, keep this in mind. It's useful if you would like to look into 4D. If it's with your, if you're in a contracting, if you're dealing with the concrete, for example, you could see it when you're pouring, when you're raising, and you can have different colors, and we identify the contract milestones in the tree diagram. And then in addition, we can include each of the major elements of the project, at least reserving space for them so we can capture the scope. We also want to include whatever points, let's say we want to have trajectories or movements, displacements later. So that was for the scheduling and modeling point of view. But what about how to generate the association file? We use color coding. What I'm showing you here refers to the various trades, and it's a classic. So it shows contracts and or the trades. We have this color code already in our schedule, and then we can generate another Excel, and then that file is read by Macro Katia. And in that file, we've included the action codes and rates, for example, for displacement or movement. So moving ahead on the macro level, we have a transfer of information into the simulation software. This includes geometry, displacement trajectory, and installation sequencing. And we can see reading from the Excel file sheets and the model software. And this generates all kinds of intermediary files, SMGSC, XML 3D, etc. So that's, you see here what it lists, what it generates. And then you come to the simulation phase. And we're still in the dryer phase, but I'll show you this later on. So for the template, what do we use? We have the various players, the dates on the calendar, the comments field, and then the .exe file. And we have that file includes the construction sequence, equipment, just-in-time handling, storage of material, movement of equipment, reserving of spaces, and identification of contracts and trades. Right now, it used to be that with 3D, via You could have something to be installed, but it's transparent right from the beginning. It becomes more and more opaque as it moves through, and then becomes 100% opaque once it's completed. So here you see 3D view. Here you see the functionalities. You have a menu. You can generate views easily. You can manage the opacity of each part fairly easily. You can rotate, zoom, or have an overview. You can filter and manage speed as well. Now for usage codes, when do we use 4D simulations? Well, in the preliminary design phase, either at concept or with detailed engineering. So this is information for planning. We use this, for example, for rehab projects, and 4D in the actual project phase as well. So during the internal tendering or the construction phase. And we use planned information or updates of timeframes, for example, and models. Ultimately, we can also have a different phase for any, well, we want to avoid claims, but with the information so that everything could be planned or updated. In terms of the level of detail, I'll have a video to show you more, but just to give you an idea, the right level of detail is the one that makes it possible for you to make decisions, and that depends on the actual project. So it has to be specific to the needs of the planning team, and ultimately we have a highly detailed level of detail to consider operational needs. At the beginning of the project, it may be more for strategic purposes to orient management. And through the whole thing, with what we've been able to develop, we can allow associations that could be one-to-one, one-to-several, several-to-one. So here are 3 usage examples. One's to give you a choice of scenario. Here you see the various prisms representing activities. And you see the time frame, which is a weekly schedule. More detailed, it is check constructability. We use this a lot. We have our start, and then you see how everything is sequenced. You have various contracts here. You have the concrete contract, the steel superstructure contract. You have to see the different colors, the 2 different colors in the model, and you see how they come in according to the dates of assembly. Then you have something that's visual, and it's very useful for the project people to understand. You have the cut planes that allow you to really understand what's happening and how it happens. And here's more detailed view for tracking control and monitoring productivity. Here you see displacements. If you see how parts are moved, and you see that with the color coding in yellow, what's mechanical, and in red, what's electrical. Another example here, you see materials being moved. You see the scheduling. You see what the schedule is. It's hourly. And here again, you see concrete being poured on all the relevant equipment. For new developments, I've been with Hydro since 2010, so it's between 2010 and 12 we use the Delmia model for our 4D activities. So for La Remain 2, then we migrated to 3D Via, which is more appropriate for our uses. So the interoperability context is more and more of a factor. You have to consider other software as well that our partners use, for example, Synchro 4D, Fuser. We want to look at all of that. And Delmia, which is also being used in 3D Via. And then maybe this is all a good way for us to be able to have some sort of umbrella over everything with 3D experience. So if I move into show you an operational support. Here's an example of 4 contracts. Here you see the cut plane, and you see the activities, the concrete superstructure. You see the turbines and the generating set being installed. 12 months was a very short time frame. We had 50,000 different parts of 3D models and 5,000 scheduling activities, and we had a deliverable associating nearly 1,000 activities in 3D, associated with 3D. And here you see the mechanical and electrical systems making up the bulk of the detail for the 1,000 associations, nearly 3/4 of them. And the added value was for the team on site, on the work site. And with all of this, we had several rounds of updates. So if I continue, I'd like to show you something else that we developed. We wanted to look at criticality. Here's an example, concrete and steel superstructure contract. So our benchmark schedule was 24 months for construction. We had about 286 associations between scheduling activities and 3D parts and components. So by doing this, the owner or client can develop a strategy for a project, and or a contractor can have a better understanding of the project. So in terms of criticality, this starts with the margin values, which are determined by the planning software. So there's an algorithm that does the calculation, or whatever your engine is, and that's included in the association file. And ultimately, you have a color code. What I'm showing you here goes from critical in red with a high margin. It goes all the way over to a high float. So there are a whole series of criteria, risk tolerance, for example, knowledge of the project team, how well the planner can speak to the project team, and the criteria can be adjusted en route. So, for example, for a given contract, you can compare. Here you see on the left the color code by contract and trade, and on right, it's the same project, and here you see the criticality in space and time. So in red, you see the more critical areas according to the chart and the values established. So it gives you a better idea of criticality, and it's extremely useful. So here's an example of the video. Here you see the initial terrain, and you see the development on the left. You see the 4D with contracts and trades, and on the right you see criticality in space and time. So we had an average of 18 tasks per month, and the average duration was 5 days each, just to give you an idea of the size of what we put in there. And all of this was with roughly 300 associations for that contract. So this is side by side, and you can set your point of view manually. And we had a cut plane that we generated en route to show you the inside of the powerhouse. And you've seen that we've been using the color code. So if I move on, here's another example. This is a 4D case where we were refurbishing and rehabbing the powerhouse. We had construction, we had the scheduling for the project, we had the operations people and maintenance people that had to be scheduled in. And on the bottom, you could see how it's moving. And that was because we had 3 rolling bridges and that were installed and moved. And we had to change the rails as well on the project. And in blue, you see how we were cleaning the rails and the beams as well. And there are 36 different groups, generators in this group, in this power station. So we did this very summarily with prisms. The issue was more at the project level for the rails and for the traveling cranes or the bridge cranes. There was a lot of complexity because we were changing the electricity direct to alternating current, and we had to have safety zones that were represented with 4D. So it was all well received. In this project, what you saw for a fairly complicated powerhouse, there were only 95 associations between 3D and scheduling activities, so it's not so complicated. And the usefulness is that we were able to present this to the operator during design reviews. And it reduced the project risks because we were able to validate the timeframes fairly far upstream. We were able to improve the scheduling scenario. It answered the operator's questions for using associated equipment for operations during the actual rehab work. And it made it possible to give the operator this 4D tool for their own purposes so that they could look into planned stoppages and maintenance work that would need to be done. Here are two examples of, again, this is an interoperability context. This is Manitoba Hydro. This is Synchro software for the Kiosk project. It's similar. Again, in terms of constructability, you see the time frame at the bottom as well. And here's a second example, Muskrat Falls in Labrador for Nalcor, done by Astaldi. And again, using Navisworks software. So other companies use other software that also do useful things, and you can look at all of these different formats. So that's that. Recommendations. Well, we recommend modeling the elements. We want to consider reservation of space if the design scale, if the model elements don't exist, and if they do exist, to model them. Obtain approved schedules from contractors where possible. Check interferences with updates, including change requests, and compare all of this with the initial scenario, as well as repeating simulations with the approved benchmark scheduling. What are the limitations? Well, you need pretty high-performing computers and appropriate software, as well as relatively qualified personnel to use the software and understand the methodology. In addition, there's a challenge to associate the people on the job site and the contractors so that you can have useful 4D that's at the appropriate level of detail. In terms of challenges, the challenges are to integrate multiple different schedules from different sources and of different formats. That's always a challenge, as well as to manually adjust for interferences. That's another challenge. Splitting the model elements to the right level of detail with the scheduling activities, that's a major cause of effort. With the simulation software, there are limitations as well. To have something fluid, you have to consider meshing with respect to the triangles of the model. There are limits to consider there as well. And finally, consider movement and displacement. That's something that's work-intensive. Still to be done is the comparison of interferences between updates and consider changes in updates. Right, in terms of contract clauses, write a little more for consideration with 4D. We'll get there. And write a manual for people on site and in-house and define the level of detail required for the various types of deliverables. That's what's down the pipeline. In conclusion, 4D simulations provide many benefits. I've seen it myself. We talked about the feasibility of a schedule, visualizing the criticality. We can help owners to prioritize sequencing and revise sequencing if necessary, and develop a project strategy, and validate execution schedules with contractors. As you know, with Hydro-Quebec, we have 3D models which are now contractual. So it's not such a big leap to have the advantages of 4D. In terms of implementation, we do this a lot for contracts that are over $50 million and that are complex. That's where the biggest value added lies. And of course, we include everything I've already mentioned, moving equipment, just-in-time handling, storage, and reserving space. Thank you. Thank you very much, Michel.